All right. Well, let's get to it. So first, I'll say thanks everyone for coming out today. I know a lot of people didn't really want to come out to this city of Brussels, and it got a lot of shit. I'll say I personally have been enjoying it, but thank you for coming out, both to the city and certainly coming out today. So I'm thrilled that you chose to join us and hear what I have to say. And you might remember last year we were in Paris, and what we talked about in Paris was kind of laying out a vision for what could be, and that was 1 year ago. And really, what I'll try to do today is tell you where we were at. And ever since then, the modular ecosystem has become a very widely used term, almost like a household name type of term, and it's become so big that it's becoming more popular to actually shit on it and take the counter position and tell you that you shouldn't spend any time on it. Now, I'm here to tell you there's a lot to get excited about, and you don't need to buy the hype. You don't need to just believe all these like Twitter influencers and just take what they're selling at face value, because there really is plenty of real things for you to get excited about. And so that's what we'll cover today. Before we get to that, I think it's worth thinking about why are we really here? We're here in Brussels probably because we care about Ethereum, the modular ecosystem. We want to see things evolve. But why are we really here? Why are we in crypto? It's presumably because we think these internet computers are really interesting. We think they could do something meaningful in the world. We think that they have some type of positive impact. And all of us, through our work, are working to increase the demand for these systems and do something useful with them. Well, then it's a little bit of a shame that we run into a very predictable problem, a problem that has elements of it being counterintuitive, counterproductive, and maybe even self-defeating, because with these internet computers, by definition, restricting digital resources and making them scarce, right? There's only so much space in a block. We limit the amount of compute that you get access to. We limit the amount of storage that you get access to. And of course, the blocks have a certain amount of size. If we're spending all of our life energy in our work to increase demand for these systems, but the supply stays the same, everyone knows what that feels like, right? Everyone's had that happen. Very, very unpleasant. And so if you think about where we are today, this problem, this scaling issue that the industry has run into pretty much every time demand has sufficiently increased, whether it was in 2017, I remember CryptoKitties, and 2021, we remember how that went, and months of ridiculous gas fees on Ethereum mainnet. By now, I feel very confident in saying that the best solution to this is the modular approach. And some people want to call it horizontal scaling. Some people call it just mini computers. Whatever it is, the concept is pretty easy to understand, which is we're just going to have an increasingly large number of computers. Cosmos folks were right. They were on this first. And now this is materializing elsewhere. And so if you think about this, right, a lot of factors are moving towards allowing us to much more easily spin up our own computer, whether it's the rollup frameworks, the rollup service providers, now shared security through things like EigenLayer, through the new ICS initiatives. All of these factor towards making it easier and easier for you to create your own internet computer. And so it's not, this is no longer a fringe view. This is probably the most widely accepted view insofar as solving the scaling problem. Well, this world doesn't really make sense unless you can connect all of these computers easily and scalably, and of course, permissionlessly. And that's where Hyperlane, which is the open framework for interoperability, that's where it comes in. And so the last 3 minutes, that's really been what we if you were here last year and you came to the talk that I gave at the previous Nebular Summit, that was the vision that I laid that there. And it was a lot about forward-looking, what's the next year going to be like, what's going to happen. And today, we're going to spend more time covering everything that actually happened, how this modular expansion has actually been put into work. So let's get to it. What is this modular expansion? We're going to look at it in action. So I don't think it's not going to be easy for me or for anyone, in my opinion, to be able to pinpoint to you who started it, who is worthy of the most credit. I think to me it's the culmination of years of work, starting with the folks on the Cosmos side, more recently folks on the Celestia side who have been pushing this movement forward. But it's also the great work from people like Optimism and Arbitrum, building really scalable rollup frameworks. rollup providers like Caldera, Conduit, Anchor, AltLayer, many others that are working to reduce the cost and effort and time of launching a rollup. And all of that's kind of brings us to where we are today. And while, again, I can't pinpoint exactly to who's the credit, but I can pinpoint what was the moment that led to this expansion phase that we're in now. And that to me is in Q4 last year when Celestia first launched and created the first meaningful alternative data availability layer. From that point in time, that's where Hyperlane really came onto the scene and started taking off, as it was being used as the primary way to bridge Celestia's asset to new rollups. Since then, we've seen it being used for hundreds of millions of worth of transactions, thousands of users that have interacted with it, several chains, and most recently, most notably, Forma, that uses it as their gas token. And now we're starting to see more rollups and the early formations of a rollup ecosystem around it. As I mentioned, right, the cost is really going down. So as I was making this earlier this week, I figured, let's time myself. Let's see how long is it going to take me to launch a rollup using something like Caldera. So on the left, some screenshots from launching a rollup with Caldera. It took me just under 2 minutes, 40 seconds to go from the moment I typed their URL to when my rollup was live on a testnet. In that process, I was able to select, the framework that I wanted, the DA layer that I wanted, give it a name, and I was off to the races. On the right side, we can see a leaderboard of rollups that are submitting data availability to Celestia. And we can see that, obviously can't see the whole list. There's about 20 of them on there. And in total, all of them, over the span of several months and many gigabytes worth of blobs submitted, they paid less than $7,000 in total this whole time. That is a fraction. I didn't do the math, but it's a truly less than 1% of what that would have cost to do the same thing on Ethereum. And so again, the cost to deploy your own rollup it's not zero, but it really is trending towards zero. And every day you're getting closer to that mark. And so, if the cost of launching your rollup is basically trending towards zero, both in time and in dollars, took me 3 minutes basically. Then how does it make sense to live in a world where it's going to take you 3 months after that to wait for your chain to get connected with others, where you're basically beholden to the good graces of some of the permissioned interoperability folks and waiting for them to either, because that's when their bandwidth frees up, that's when they get the time. It doesn't make any sense, right? So this world that we talked about, this modular world, it, in my view, really only makes sense if you have a permissionless, scalable, and extensible way to connect those blockchains. And again, that's where the open framework for interoperability, Hyperlane, comes in. And if it wasn't clear already, I'll tell you, simply put, modular blockchains really like permissionless interoperability. So from that moment where Celestia launched, if you've interacted with Hyperlane, that was probably the first time. I have the little tweet here that announces that. Over $900 million in TIA has been bridged back and forth by tens of thousands of users over the course of several 100,000 transactions. And this is not even including the numbers from more recent initiatives like Stride launching Hyperlane and operating it by themselves and delivering it to TIA and soon to many more chains, which is something we'll talk more about. And I personally am exceedingly excited about. After that, a few months after that came Injective, which launched an EVM rollup. Injective was using Hyperlane for their gas token. So the only way to get the gas token onto the rollup was using Hyperlane. That too had tens of thousands of addresses transacting with it. Over $700 million went through that path. And then Hyperlane really started to take off. Here we can look at some of the numbers, the more important ones in my view to kind of tackle. In that period throughout the year, over 4 million interchain messages were processed. Over 200,000 distinct users in some months. The number of contracts that interact with Hyperlane kept increasing, and over 2.4 billion in volume went through Hyperlane routes. Now, the coolest thing about this only captures the numbers that are operated by our development company. All the self-hosted versions of Hyperlane are not captured here. We're working on a solution for that now and hope to have it in the next few months. And so, in reality, these basically are the floor of what the numbers have been. The thing I'm personally most excited about is the permissionless expansion of Hyperlane. I mentioned Stride before, but it's not just Stride, it's Forma, it's Kerak, and then there's several, almost a dozen more that are marching towards production right now, and over 30 that we know about that are in earlier phases with their Hyperlane, like self-host journey, where they are taking care of security, operations, and doing all of that, and they enjoy it because they're able to monetize that. It's not just that they can get it on their terms, on their timeline. They can also turn it into a business opportunity, so it can be a profit center instead of a loss leader. And that indistinct rectangle, that is a screenshot from the registry that we've created in our GitHub that allows people who deploy Hyperlane through the Hyperlane CLI to register their chain, and that keeps growing. Just the other day as I was making this, I wasn't even expecting to find that, but 3 new pull requests by chains that are launching close to launching Hyperlane themselves. So I told you that Hyperlane is an open framework for interoperability. How else has it manifested other than just people hosting it themselves? Well, expansion to new virtual machines. Hyperlane today is live on Ethereum, it's live on Cosmos through CosmWasm, and it's live on Solana. And both the Solana version and the CosmWasm version were started by teams other than the core team. In fact, the CosmWasm work was not just started, but also taken past the finish line and productionized by the Mitosis team, a bunch of CosmWasm experts who are now doing a cool liquidity layer. We'll talk about that a little bit later. As we speak, many different teams are building Hyperlane for different virtual machines. The Pragma team, which is one of the biggest oracles in the Starknet ecosystem, is building Hyperlane for Starknet. Movement Labs built it for Move. The Fuel team is working on finalizing a version. Cadena, Rootstock, and several others all doing this. Now, why would they be doing that, right? Normally, you don't see external teams like trying to give you the, different VM version of a certain interoperability protocol. That's almost always the core team. Well, that's because those are generally closed and permissioned platforms. With Hyperlane, that's different. All these players realize that they can run it by themselves, they can monetize it, and that no one has the ability, certainly not the core team, has the ability to stop them from using it. And in fact, in an effort to make it easier for anyone else, we've put together an implementation spec on exactly everything you'll need to be able to convert Hyperlane to a VM of your choosing. And so this is what it means to be an open framework. Other people are contributing into it. By now, it's over 15 teams that have made some type of meaningful contribution to the Hyperlane code base. Some, like Mitosis and Stride, have made massive contributions. Others are on their path to making massive contributions, like the Pragma team. And others have made not as large, but still very meaningful and useful contributions. And so we talked a lot about kind of the numbers, the evolution, what's happened, but let's give you a few minutes to talk about what you can do with Hyperlane. So usually when people think about interoperability, they immediately think about some form of bridging. So the out-of-the-box bridging concept with Hyperlane, where it allows you to permissionlessly deploy bridges through our CLI, is what we call warp routes. Whereas normally a bridge kind of looks like all the people put all the assets into a single contract with one fairly rigid security setting. Warp routes get the benefit from Hyperlane's modular security architecture, where you can set the security module per route, and they are individualized per asset. So in fact, if you're the asset issuer, now you can either completely own the security of your bridging or at least play a part of it. And we'll go into more depth in that in just a moment as we cover one of the more recent routes that just launched, where the issuer is the person securing the transfers. But wouldn't it be cool if while your assets are sitting in that bridge, if they could actually be put to work, if you could earn some yield on them. Everyone's probably already familiar with what Blast did in the last 6-7 months with their kind of native yield bridge. At Hyperlane, as a matter of course, we like taking things that are difficult to do and are closed off and making them open, accessible, and free for everyone to use. And yield routes is our attempt to bring that to this concept of native yield bridging. So today, through our CLI, you can launch a yield route, which works very similar to a traditional warp route, except what happens is once you deposit into it, you would configure which vault you want it to go into. It can go into any 4626 vault. And while your assets are, let's say if you're moving from Ethereum to, let's call it Neutron, while those assets sit on Ethereum, they're earning yield. And whenever you're done with your escapades on Neutron and you want to go back to Ethereum, they get redeemed from that vault. We're adding features to this. Right now it exists in kind of like a proto version. A few teams are bringing theirs to production over the next couple of weeks. And some of the features that will come online before the end of the summer will let you more easily distribute the yield and decide how you want to split it. Some cases you might want to keep it all to yourself as the owner of the route and use that as a revenue source that you can improve your business with. Some cases you might want to give it all to your users, and in some cases you might land somewhere in between. So a warp route in action that we can look at is Renzo's Easy ETH. Renzo is one of the largest liquid restaking protocols. They launched this route on June 19th, and since then, as of Monday of this week, had over $700 million in value already transferred with a single-day high of $100 million. It was launched with a set of 8 chains where once you deposited from Ethereum, you were able to move freely between any of those 8 without any additional deposits or locking or anything of the sort. And the coolest thing about this is Renzo is in the business of securing activity on blockchains through their liquid staking protocol and their group of operators. They're the ones who are the ultimate entities securing this bridge. When you are transferring through it, Renzo's validator has to sign off, and if it doesn't, the transactions just don't go through. It's one of the Renzo associated operators that has to sign off. That's something that right now you can only do through a platform like Hyperlane. And this is something that we're very excited about. And so if you're an asset issuer and you're interested, feel free to mess around with the Hyperlane CLI that lets you deploy a warp route, a yield route, anything of the sort to the chains of your choosing. And you could even play a role or be the sole entity that secures those transfers. So the CLI, if you're bored, feel free to pop out your laptop and you can mess with it as we're talking about things right now. You can see for yourself that it'll allow you to deploy all the necessary Hyperlane contracts to any chain you'd like, manage that deployment, deploy new routes, manage those, and really think of it as just your main access point to this open framework for interoperability. So in the interest of time, we'll run through some of these other live use cases in the wild that are not necessarily bridging related, but are doing something cool with Hyperlane. Aave uses it for their governance messages. When something passes on Ethereum, they use Hyperlane to propagate that through other deployments of Aave on a number of chains. Superform is an app that allows you to deposit on one chain and then get exposure to yield opportunities from other chains. Runs on Hyperlane to enable that. Mitosis, building a liquidity layer. Yes, that's the same Mitosis that I mentioned earlier that had built the CosmWasm version of Hyperlane. And Everclear is about to go live with their Interchain clearing layer. And so that's all we got for today. I know I'm a little over time, so sorry about that. But if you want to learn more, you can go on our docs. You can join our Discord. Follow us on Twitter at Hyperlane. Check out the site at hyperlane.xyz. And of course, feel free to shoot me an email or send me a message on Telegram. And thank you.